Okay, another installment of Mr. Shaw Does Your Homework. Find the area between the graph and the v equals 0 line. Remember, this is the distance, or basically this should actually say, you guys know what this should say, this should say displacement. Mr. Shaw often mistakes these words himself, confuses them. This is displacement. The object travels. Okay, now what are we talking about, guys? We're talking about this area, and this area. Between the line and your v equals 0 line. These areas, this area here, again, get it all the way filled in. This area here, side to side action. This area here, a little bit more side to side action. And there we go, guys. That's what we're trying to fill in. We're trying to find the area of these blue spaces. Luckily, I can just do that. Alright, guys, so let's just do this. Let's make a mark. I'm going to make a mark here and a mark here. Now you'll see the space that I've made here. Whoop, don't move that. Leave that alone. So I've made a nice rectangle here. It's 1, 2, 1, 2, 3, 4, 5, 6. 2 by 6, it's 12. It's on the top, so it's positive. Then you've got a nice, you can have a nice rectangle here. Let's go with this rectangle. That one has got a 2 value. And then we have this. That's also got a 2 value. Now you take a look. You have, this is 1 and 1, so plus 2. So here we have, this is our first area that I've done in blue. And let's switch colors and do it in the next area in red. Okay, so we can do this. So I have 2 triangles and a rectangle. Now the thing you notice, guys, if you could actually take this triangle, maybe you could fit it into this space, you'd see that it would go there. These are both 2 by 4, which is going to be 8, times 2, which is 16. That's negative. It's below the line. And we'll come back to our good friend blue to above. Actually, we'll do green. And we'll take a look. This guy, this is 1, 2, 3, 4, 5. 5 by 2 by 1/2. Well, that's just 5. It's on the positive side, so plus 5. Okay, let's add them up. Well, here we've got 18, 23. It looks like, once again, this is going to be 18. 18 minus 16 plus 5. Well, that 18 minus 16 is 2 plus 5 gives you 7. Plus 7 meters. Now, a lot of people always ask me, why is it meters? Well, let's just answer this and hopefully put this to bed right now. If you have this side of your rectangle, that's going to make meters per second. And let's say you have this side of your rectangle, that's time. And you multiply those together. We'll put that over 1, and what you'll immediately see, guys, is this phenomenon happens, canceling out. This cancels out, and this cancels out, and you're left simply with meters. Very cool. Up, went too far. Let's zoom out a little bit so I can see. So, write everything you know about the motion of this object in one paragraph or a series of bullet points. How fast is the object traveling, and for how long? Constant velocity? Or constant/uniform acceleration? Well, let's take a look. I'm going to clear this off. Sorry, guys. Once again, positive 7. It's going to be gone. If you're wondering what I'm hitting, it's Control Z. Control Z will erase things. So I'm just going to write this. From t equals 0 to t equals 2. Take a look. From 0 to 2, what's going on? Constant velocity of positive 2. I'm just going to say v equals 2 meters per second. And this is a constant velocity. I'm not going to put anything on top of this. Okay? Now let's take a look. What happens from 2 to 4? Take a look. This was from 0 to 2, but the second I get to 2, my motion changes. Now from 2 to 4, my velocity, what's on my y-axis, actually increases. Increase in velocity, you'll say? Mr. Shaw, I've heard that's the kids call that acceleration. So, from t equals 2 to 4, and I'll put some seconds on here. I can see you guys being upset about that. we will have a VI equal to 2 meters per second. We will have a VF. Where do we stop at? Up 4 meters per second. I didn't write my 4. Equals 4 meters per second. And we'll have acceleration. Now, what's my acceleration going to be? Well, we can just look at this and see the slope. We're going up 1 over 1. Just have an acceleration of 1. And there we go. That's all I know about the first one. All right, let's give myself a little more space to write about this further. Oh my goodness, I'm running out of room. Okay, let's see what I can do. From t equals 4 to t equals 5. What happens? I'm going to write in this space right here. T equals 4 to t equals 5 seconds. Oh, that didn't come out looking like an S at all. Well, you guys can deal with it. So, from t equals 4, which is right here, to t equals 5, we're going to have a constant velocity of 0. Oh, no. Oh, mistake. No, we're going to have a constant velocity of 4. And that's meters per second. And if you wanted to write, you could say acceleration equals 0, because slope is 0. That would also be right. Now, I'm going to clear this off so I have some more room. All right, everything's cleared off. Now, from t equals 5 to t equals 9, something happens. But actually, let's stop right here in the middle, because something important happens there. So, from t equals 5 to 7 seconds, we go from a VI at this point equal to 4 meters per second to a VF equal to 0 meters per second. Okay, very important. Now this happens in 2 seconds. So you'll notice, guys, if you just take these and divide by the time, you take your change in velocity and divide by time, well, your change is 0 minus 4 meters per second over your change in time, which was going to be 7 seconds minus 5 seconds. You'll get your slope, and that's also your acceleration, and you should get a slope of 2 meters per second squared. Okay, great. Just going to remove that so I have more room to work. And that is Control Z. You can move. And that is our acceleration. Okay, so we've got that part done. Now, let's talk about this. We're going to come back to the importance of this real quick. And I think I might stop after this point. Hopefully you guys get the gist of it. Here, from t equals 7 to t equals 9, t equals 7 to t seconds, t equals 9 seconds, you go from a VI of 0 to a VF equal to negative 4 meters per second. And if you carefully look at this, your acceleration again is still, this is supposed to be negative, it didn't transfer over. A is still negative 2 meters per second squared. That's interesting, guys. And what we'll see here is this. This is actually uniform or constant acceleration this entire time. And this point right here is very important. When you cross the 0 line, you actually change directions. This is an object moving forward, comes to a stop, and turns and goes back in the other direction. This is almost as if you're running out of your house to school and then you realize you forgot your protractor and you had to run back and get it. So at one point you'd have to stop, turn around, and run back. And that's what's happened here. Okay, hope you found this video informative.